Welcome to the video lecture Digital Communication. This is Samada Pratima, Assistant Professor, EC Department, RMK CET. In this video lecture, you are going to see the topic I pattern from the Unit 3 Baseband Transmission and Reception. In general, in digital transmission systems, its quality is evaluated using a bit error rate BER. So, if the bit error rate is good, high, then it is said to be having good quality. And if the bit error rate is not up to the mark, then it is said to be degraded. Now, this degradation of quality will be analyzed with the help of I pattern. The I pattern will represent the how much the system get degraded. Now, what is I pattern, and first of all, why it is called as I pattern? Since the graph will be looks like a human eye, that's why it is called as I pattern. It is actually experimental tool which gives the information regarding the degradation of quality of a digital communication system. It evaluates the effect of ISI, intersymbol interference, as well as channel noise. Now, how it can be plotted? It can be plotted by using a cathode ray oscilloscope, CRO. We know that in CRO, to display any waveform, we have to give input to a vertical deflection plates, and the timing signal will be given to horizontal deflection plate. We know that the CRO is having two deflection plates, vertical and horizontal. So, to display I pattern, we will give a received wave to the vertical deflection plates and a sawtooth waveform having the same bit rate to horizontal deflection plates. That is, a sawtooth waveform is synchronized with received waveform. Thereby, we can plot I pattern using cathode ray oscilloscope, CRO. So, actually the I pattern is a composite signal that reflects the channel bandwidth, attenuation, jitter, rise and fall time variations. So, all the above factors will be determined or analyzed with the help of I pattern. Now, the inner region of the I pattern is called I opening. An I pattern provides great deal of information about the performance of the system. It will give how effectively the system transmitted the waveform, how much it get degraded. So, it gives a good information regarding that. Now, let us see, this is the transmitted waveform which get distorted after traveling through the channel. So, this is received distorted waveform. Here bit 1 and 0. So, we can consider this as the polar representation, where the 1 is represented by a positive voltage and the 0 is represented by a negative voltage. So, this we can consider it as for binary data the polar representation, which you have seen in second unit. You know different types of line codings and different types of wave representations. So, one of the representation, that is a polar representation, in which the plus voltage will be used to represent bit 1 and a negative voltage will be used to represent bit 0. Now, if we give this incoming distorted binary wave, that is received digital signal, to the vertical deflection plate of the CRO, and a sawtooth wave at the rate 1 by TB to the horizontal deflection plates of CRO, then this CRO will display a waveform like this, and this is this graph is resembles like a human eye. So, it is called as I pattern or I diagram of the digital transmission system. So, here using this interior region of the I pattern is called as I opening, and it will give the information regarding the degradation of the digital transmission system. Now this is also eye diagram or eye pattern. This will be used for theoretical information, theoretical analysis of eye diagram. So here this horizontal distance, this distance will gives you best time interval to sample to get sample, and this height will gives you the margin over the noise, and at the best time sampling time, how much distortion, that time also distortion will be presented at best sampling time also, but it is very small, and this distance will gives you the distortion at the sampling time. Now how much sensitivity it is to the timing error will be given by the slope of the eye pattern. This slope will gives you the sensitivity to the timing error. Now at zero crossing points, zero crossing means it is cross this x-axis. The bit 0 and bit 1 will be cross this, since we are representing pulses, either negative voltage or positive voltage of bit duration TB. So definitely it will cross this x-axis. So at that time this there is some difference. So this area will gives you the distortion of zero crossings. Because of zero crossings we will have this type of distortion. So this is called width, and this is called height, and this is called the slope. So width, height and slope of the eye diagram will gives you the parameters to analyze the distortion of the digital transmission system, and it will also give the best time for sampling. So the same will be represented in this slide. The width of the eye opening defines the best time interval to sample it, and we can avoid, we can eliminate the intersymbol interference if we sample at that time, and if eye open is widest, then that is the best time for sampling, and the sensitivity of the system to the timing error is determined by the slope of the eye pattern. Next, the height of eye opening at the specified timing sampling time defines the margin over the noise. Now if ISI is severe, so we cannot avoid it, we cannot eliminate. So if ISI is severe, what will happen means the eye will get completely closed, and it is impossible to avoid error due to the combined presence of ISI as well as noise in the system. So if eye is open, then only we can able to eliminate the ISI, we can able to receive information from the degraded version of received signal. If eye is completely closed, then it will indicate that the ISI is severe, we will lose the information at that time. This is nothing but for M array signals. This is a practical eye pattern diagram plotted using CRO. Here 1, 2, 3, 4, 5, 6, 7, 8. So 8 array pattern. This is nothing but for M array signaling. The eye pattern will looks like this. I hope you have understood something, better understand that what is eye pattern, why it is called as eye pattern, and the importance, the significance of the eye pattern, and the parameters involved in the eye pattern. Thank you all.